To really know what makes a great city work, you have to peel back its skin and expose its secret life force. A system of incredible complexity and technology that millions depend on, but few understand. A fantastic voyage now begins. A journey deep inside the world's megacities. On the shores of the Arabian Sea, in a man-made setting, nestles the jewel in India's crown, Mumbai. Once called Bombay, it's India's largest city. Mumbai was built on 7 islands, merged as one, buffeted by monsoons and bursting at the seams. A space the size of Barbados holds a population greater than Greece. 13 million people, and growing. To survive in this sea of humanity, you need lifelines of asphalt and steel. In this megacity, public transportation is the most vital organ. The city can't live without trains and buses. But this circulatory system is in for a shock. By the year 2020, Mumbai will swell to 28 million people. The world's largest city. To prevent paralysis, Mumbai needs radical surgery. But the operation won't be easy. The problem is geography. Trains run mainly north and south, between suburbs and downtown, on 2 lines, the Western Railway and the Central Railway. Every day, more than 200 trains make more than 2,000 trips along 300 kilometers of track. They carry more passengers per kilometer than any railway on Earth, a system taxed to the limit. To ease the crush, Mumbai has launched the largest public works project in its history. An elevated freeway, the first double-decker flyover in India, to bypass the busy tracks below. A 4-kilometer sea bridge like nothing ever built in Mumbai, to bypass congested roads. And an entire new metropolis, the world's largest planned city. The project will employ thousands of workers and cost billions of dollars. But will Mumbai's future arrive in time to rescue the rails? Every day, 88% of commuters take public transportation. Trains alone carry 6 million, equivalent to the entire population of Israel. During rush hour, a new train arrives every 3 minutes. The trains were built for 1,700 passengers, but they carry 3 times that number. The crowding is so notorious, the railways give it a name, the super dense crush load.
During peak hours, you have 3 or 4 people standing in the place of 1 person. You don't find a single empty spot here.
Surekha Yadav has felt the crush firsthand and witnessed the first attempts to relieve it. Mumbai is one of the world's few cities that runs trains just for women. Inaugurated in 1992, the Ladies Special eases the commute of working women and keeps them out of the super dense crush. But some women like the pressure. In 1989, Surekha decided to move from the cabin to the engine. She's Asia's first female motorman. 10,000 trips later, Surekha prepares to start her first run of the day.
This may look pretty straightforward, but my hands, feet, eyes, ears, all my senses have to stay alert at all times. If even one stops working for a bit, accidents can happen.
And they do. People die on these tracks every day. When she drives, Sureka has her hands full. One hand to accelerate, one to brake. The mechanism is named for a worst-case scenario, the dead man's handle.
If something happens to the motorman, if he faints or something, and if the handle gets released, the traction cuts off automatically. The emergency brakes activate and the train comes to a halt.
As a second fail-safe, the rails have a built-in traffic cop. It regulates two trains running on the same track. It also allows motormen to make time on a railway where every second counts.
We stop for only 20 to 30 seconds and then leave. We have to start within that time because we have to run according to the timetable. Otherwise, we won't reach the next station on time.
With just minutes between trains, a single delay can ripple down the entire line. To keep Sureka moving on time, human eyes follow her down the track. A railway version of an air traffic control tower. Like its airplane counterpart, it stays in constant contact with the motorman running the trains. Today, Sureka is watched by the Central Traffic Control Room.
Malad, 827 through line following 33.
On an entire wall, an electronic map shows the movement of every train on the system in real time. A red line indicates a train. A green line, the train's route. At peak hours in the Western system, 409 trains move along 4 tracks.
A train coming late to my system will affect all the other trains. After every 3 minutes, we have got another train. So suppose something happens to the first train, it's like a dominoes effect.
As the control room supervisor, Pranay Prabhakar must keep the dominoes from falling.
From this room only, we are moving 3 million people a day. That's the lifeline of this city, there is no doubt about it.
If the lifeline snaps, commuters flounder.
There are 4,500 people in a train, approximately. So I stop a train, 4,500 people are stranded. So a quick decision-making is the essence of the system.
The decisions fall to the control room officer. Like an air traffic controller, he's bombarded with information. A constant stream of updates from several hundred motormen and station masters.
If there is some problem, then the job of coordination between all these fellows is of his. Because he is the only man who has the entire picture.
Time was when the picture was cloudy. Before the electronic map, information was relayed from station masters to the control officer by phone as each train passed. Every minute, each controller received a dozen updates about scores of trains. The result? An information pile-up that could trigger a system-wide backup and a commuting nightmare. Now, the control room officer can talk to several hundred motormen at the touch of a button.
So they have got time for now quality decision-making. They can act faster. They give instructions to the motorman, partner, you're running late, make time.
A train is Mumbai in miniature. Too many people, too little space, and not enough time. A formula for tragedy. Every day on this overtaxed system, technology and desperation collide with tragic results. Riders and drivers so desperate to buy time, they risk their very lives. Every year in Mumbai, 3,500 people die on the train tracks, an average of 10 per day. Hundreds more are injured.
I was standing in the other train platform, waiting for a train, when someone pushed me from behind. I fell right there on the train tracks, and I saw the train coming towards me. When I saw the train, I immediately ran, but the train was so close. The train ran over me. 8 compartments ran over me.
Jayant Vasani lost a leg through no fault of his own. But thousands of victims step into harm's way on purpose. No fences line the tracks. Anyone can cross anywhere. More than 7 million of Mumbai's inhabitants live in shanty towns near the rails. For them, crossing the tracks is like crossing the street, only deadlier.
It's faster, maybe a minute faster. They don't realize that saving a minute may cost them a life.
At every station, an overpass allows pedestrians to safely cross from one side of the tracks to the other. Some use it, some don't.
There is nobody in Mumbai who hasn't seen such an accident. Somewhere or the other, this kind of accident happens. Even then, people keep rushing.
So do the trains. In Mumbai, even death runs on their timetable.
When an accident occurs, we feel terrible, but we don't keep it in our minds because we have to move the train forward. All the other passengers have to reach their destination.
The railways post warning signs against trespassing to no avail.
Life in Mumbai is really hectic. Every minute is precious, so people keep running every day. Time is more precious here than life.
In this megacity, the tracks are dangerous, yet the trains are safe. Mumbai's railways have one of the best safety records in India. No trains have crashed in living memory. It's no accident. Every train is equipped with electronic safeguards.
Whenever we pass a yellow signal, the hooter starts beeping. We call this a vigilance button and we press it. Normally we control the speed ourselves, but when we press it, the system will automatically control the train's speed.
It's called the auxiliary warning system. It's like a mechanical co-pilot. It interacts with the signal system to control the train's speed and avert disaster. Near each signal, embedded in the track, is a transmitter. As the signal changes, so does the frequency on the transmitter. As a train passes over, the transmitter checks the train's speed against the signal's color. Then the transmitter beams its frequency to the train's auxiliary warning system. If the train is going too fast for a yellow signal or on the verge of running a red signal, the auxiliary warning system will either warn the driver or stop the train. An even more advanced system is about to be deployed to avert disaster, the ACD, or anti-collision device. A microprocessor is linked to a global positioning satellite device on the train's roof. GPS tells the microprocessor the train's position. The position is then radioed to all other trains within a 5-kilometer radius. If 2 trains should approach each other on the same track, their computers will send a message to an automatic braking unit. Stop. The ACD is a brand new invention of Rajaram Bochi. To prove it can work in Mumbai, he's putting his neck on the line.
There is a stationary train here. you'll see an approaching train to the station. And I will stand right in the middle because I have the confidence that both the ACDs will make the trains stop.
All that stands between one man and 100 tons of locomotive is his own brainchild. Bochi's confidence is well placed. The ACD automatically stopped the train. On a busy track, the ACD would stop the trains even farther apart, up to 100 meters. Over the next 4 years, 35,000 ACD units will be installed all over India, including the trains of Mumbai. The technology will not only reduce accidents, it will increase capacity. With the ACD, twice as many trains can safely run on the same track. The time between trains could be slashed in half to as little as 90 seconds. That's 40 trains per hour into every station on every track. Now that's rush hour. Mumbai is harnessing technology to keep the tracks open and the trains moving. But against one force, this megacity is powerless. Monsoon season. From June to September, more than 2 meters of rain may fall. Every summer, the rain is so heavy, this low-lying city is flooded. Tracks are inundated. Trains stop running. Mumbai itself grinds to a halt. And the water works to undermine the tracks. Rust, runoff, and rivers of debris. When Mumbai dries out, crews inspect the system, then resume the endless maintenance of 300 kilometers of aging track. The challenge? Repairing a transit system that never stops running and suffers more wear and tear than any other railroad.
Every 3 minutes there is a train on this track.
Arunandra Kumar is Mumbai's Director of Railway Maintenance. Every Sunday, he shuts down a short stretch of track to perform the railway equivalent of a physical exam. They call it a jumbo block. Some 200 workers from every department converge to perform a lot of work in a little time. They inspect everything from wires to sleepers, signals to rails. Like most checkups, a jumbo block includes an X-ray. Over time, minor cracks form in the rails. When a crack ruptures, it can cause a derailment. To detect cracks, Kumar's crew uses an ultrasonic flaw detection machine. It's like ultrasound for rails. Ultrasound waves scan the metal and produce a sonographic image. If they find a crack, they operate. Like a surgeon removing a tumor, they cut out the defective rail.
So if the cancer has been detected in time, it is removed and healthy part is there in place.
The standard joint for attaching 2 rails is a fish plate, a metal bar bolted through the side of each rail. The fish plate leaves a small gap between the rails so they can expand in hot weather. When the wheels pass over this gap, they make their trademark clickety-clack. But under the car's enormous weight, the joint comes loose and exposes a train to derailing. The new rail has a built-in expansion joint. One rail overlaps the other, leaving a small gap underneath.
And this gap is most crucial because it provides for the expansion of the rail as the temperature goes up. And it is more sturdy as compared to the original fish-plated joints because it does not provide a kick on the back on the wheels.
After rails are inspected and repaired, the work is checked by machine. A big machine. Called a tie tamping machine, it performs 3 crucial tasks. It ensures the rail ties are secure, adjoining rails are even, and opposite rails are level. To stabilize the ties, the machine performs a gigantic shifting operation. 8 steel claws grip the rail and lift it up to 50 millimeters. The machine then tamps down the ballast around the ties to ensure they don't shift. Next, an onboard computer measures the alignment of the rails. If they're misaligned, it calculates the correction and levels the track. This one machine can inspect 800 meters of track an hour. The same job would take 65 men. The tie tamping machine eliminates 3 problems, but leaves one behind. As it lifts the rails, it makes them less stable. So another machine comes along to press them back into place. The dynamic track stabilizer is equipped with a pair of rollers on each side. As it rolls down the track, the rollers vibrate the rails with the force of 100 trains. And the result? The rails are settled and stabilized. When the track reopens, the ride may be crowded, but it won't be bumpy. Week after week, Kumar's crew will move on down the line. Working in concert under his direction.
It's a pride to manage diverse things like an orchestra playing well. It can produce sound, it can produce music. It's my job to see that music is produced day in, day out, all the time.
Most of the time, they make beautiful music, but they perform with an overtone of danger. In this job, you can lose a limb or your life. Perils, heavy machinery, high voltage wires, and the trains themselves. One false note, and it's curtains. To safeguard Kumar's crew, someone has to ensure the track remains closed and the wires remain dead. That someone works here. Far removed from the line workers, but guarding their very lives. This is the traction power control room, the heart of the railway's electrical system. From this room, they send power to every wire, train, and track on the line, and cut power for maintenance.
We put the danger caps to ensure that nobody by fault he switches on the power supply. If somebody accidentally switches it on, then maybe some people can lose their lives.
Vineeth Kumar is an electrical engineer for Central Railways. From his command post, he can detect a power failure in any section of track and pinpoint the cause.
And now the supply has been cut off.
All of Mumbai's trains run on electricity. It flows not from a third rail, but a mechanical arm called a pantograph, which receives power from a wire called a catenary. It's worked for 8 decades, but now this system is in for a jolt. Mumbai was India's first city with an electric rail system. It came online in 1925, and it's showing its age. It's a DC system, operating at low voltage but high current. Miles of wires run above the tracks, carrying electricity from a network of substations. The DC current runs from the substation to the catenary, then to the pantograph, then into the cabin. At the throw of a switch, power flows into the traction motors and moves the train. But DC current poses a triple threat. It's expensive to run, expensive to maintain, and it requires many substations. Now Mumbai is making the switch to AC, or alternating current. It needs less power, less maintenance, and far fewer substations. Most of all, AC will allow the railway to grow. Mumbai is laying more track to run more trains. DC substations can't handle the extra load. AC can, because it distributes the electricity more efficiently. New track can't come soon enough. Like a runaway train, this megacity's swollen population has outstripped its infrastructure. Mumbai has tried to ease the crowding by adding cars. Trains that pulled 9 cars now pull 12, a 35% increase in capacity. Yet they're still more densely packed than any on Earth.
Nobody wants to travel in such crowds without any comfort. But what can you do? There is no other option except the train.
And the crowding will only get worse. Mumbai is on track to become the most populous city in the world.
India is a country full of people. Bombay is a city that attracts them.
Mumbai is both the New York and the Hollywood of India. Capital of finance and center of entertainment. People come from all over South Asia to chase their dreams. Few guess how bumpy that ride can be. For city and citizens alike, the road to success is about to take a sudden turn. In Mumbai, lunch is set to the railway timetable. Now arriving, the world's biggest conveyor of meals on wheels. Every day, trains carry 200,000 custom-made lunches. The meals are delivered by 5,000 white-garbed couriers, the dabowalas. From preparation to distribution, this century-old system is a model of efficiency. And the linchpin of the entire operation is the railroad. In India, custom dictates what you eat and who prepares it. In some places, eating out is not yet in. Every day in the suburbs of Mumbai, thousands of wives make lunch for thousands of husbands. Each meal goes into a reusable canister and into the hands of a dabawala. At each train station, the canisters are sorted by destination. Servants of the train's unyielding schedule, the dabawalas have to hustle. They have just 30 seconds. This may be the world's only large-scale delivery system that works without documents. 200,000 lunches every day and not a shred of paper. Paper wouldn't work. Most dabawalas can't read. Yet their low-tech system of colors, numbers and letters is almost foolproof.
This is the code mark for the station. This 9 code is for the person who makes the delivery. The market it goes to is marked here as M. That's the code for the market. And the D0 is the number it is delivered to.
Ramachandra Sate has delivered lunches for 27 years. He hasn't mixed up a single order. If he ever did, someone wouldn't eat.
Because the people who eat from these boxes come from all castes. If you give a man from South India the food from a Muslim family, he can't eat it. He won't even open it. So we never mix up the boxes.
He's not exaggerating. The dabawala system is recognized as one of the best managed supply chains in the world. Forbes magazine awarded the system its highest rating, Sigma 6, a rating shared with corporate giants like General Electric and Motorola. Sigma 6 means no more than one error per 1 million transactions. Only two things can derail the Dabawalas. One is their own lifeline.
Our life itself depends on the train. If the train comes to a halt, so will the Dabawalas.
The other obstacle? Growth.
Trains used to arrive every 7 minutes. Now it arrives every 3 minutes, still packed.
Twice as many trains, yet the crowding is worse than ever. Mumbai is a victim of its own success. 4 centuries ago, Mumbai, then called Bombay, was a cluster of fishing villages with a deep harbor and a tiny population. As the British colonized India, Bombay grew. In the 1800s, through vast landfill projects, British engineers combined the 7 islands around Bombay into one. When the American Civil War strangled the cotton trade, Bombay filled the void and got rich exporting cotton. When the Suez Canal opened, Bombay became one of the greatest ports on the Arabian Sea. The 20th century brought independence from Britain. As in so many former colonies, a rash of renaming has swept India. Bombay was renamed for an ancient goddess, Mumbai. New name, new problems. In the past 3 decades, Mumbai's population exploded. Its economy boomed. Its middle class ballooned. And traffic stalled. As more people can afford cars, streets are becoming parking lots. In some places, traffic is so thick, it's faster to walk. Most cities would try to divert drivers onto trains. Mumbai can't. The trains are already bursting at the seams. Mumbai needs pavement, but it's running out of land to pave.
So what do? Either we build roads in the sky or we build roads in the sea. So we have taken to the sea at the moment. We are not yet ready to make the roads in the sky.
Anil Lakina is in charge of building a road to relieve one of Mumbai's worst bottlenecks.
If we make a ring road around Bombay in the sea, we can take the traffic off Bombay onto the sea.
Today, a mirage rises from the ocean. An 8-lane bridge, 4 kilometers long and 30 years in the dreaming. The Bandra-Worli Sea Link. Most of the bridge will be prefabricated off-site, then assembled like a giant jigsaw puzzle. The bridge's piles will be driven 30 meters below the seabed. Atop each pile, a concrete pier weighing up to 500 tons, a total of 180 placed 50 meters apart. Then come the segments that will form the roadbed. Each is aerodynamically curved to deflect the monsoons of Mumbai. The bridge can withstand winds blowing 125 kilometers an hour. The indispensable workhorse, a 1,200-ton gantry crane that moves forward as the bridge progresses. At 2 channels, the bridge takes a flying leap. Suspended from 424 cable stays, stretched from 2 soaring towers, the higher one 138 meters above the seabed. Working from both ends, crews will meet in the middle. When complete, the entire bridge will weigh about 340,000 tons, the weight of 7 Titanics. This engineering marvel is so spectacular, it's expected to become a tourist attraction. It's also built for a lifetime.
We have designed this bridge for the next 100 to 120 years.
Longevity is built in. At peak production, engineers pour 150 cubic meters of high-performance concrete an hour, enough to fill 25 truckloads. Denser than normal concrete, it takes up less volume but packs more strength. It's treated with silica fumes to plug gaps and make it waterproof. To protect the steel rebar from saltwater corrosion, the concrete is mixed with a coal byproduct called fly ash. As a second line of defense, the rebar itself is coated with an epoxy that seals out oxygen and rust. The segments are the biggest and heaviest ever cast in India. Each weighs between 120 and 140 tons. Each segment is numbered, then hoisted into place like a bead on a string. Construction progresses one segment at a time, one span at a time. From pier to pier, 17 segments form a span. 15 in the middle and 2 on the ends atop piers. The segments are stitched together with 28 high-tensile steel cables as thick as a basketball, anchored on the pier segments. As the bridge leaves landfall, construction moves out to sea. Segments will be floated on barges, then hoisted into place. The fish belly shape of the segments will reduce the force of the wind by 25%. Wind will flow under the segments the same way it flows over an airplane wing. This streamlined flow reduces the disturbing force of drag and protects the slender deck from stress. The fish belly shape was developed in Germany and tested in a British wind tunnel.
My problems are not unique, and my solutions can be easily borrowed from the other parts of the world.
Mumbai doesn't shy from seeking advice. It's importing experts from China to construct something India has never built. A structure to accommodate not only the flow of cars, but ships. The waters below the bridge are heavily trafficked. To extend the footings from shore to shore would block the channel. Solution, the cable stay bridge. For 2 stretches totaling 950 meters, the bridge will be suspended from stays. In turn, the stays transfer their load to the pylons. Together, the deck, stays and pylons form that most stable of shapes, the triangle. When the bridge opens, congested Mumbai will heave a sigh of relief.
We should be able to get about 15 to 20% off the rail, on the road, and to the waterways.
Diverting traffic over water will relieve part of Mumbai's congestion. Changing direction will relieve more.
You only see people traveling from north to south and back. We are now finding methods of connecting it between east and west.
East-west travel has long been hampered by some of the world's busiest railways. Mumbai's trains run north and south, just minutes apart. Building a road across the tracks would only create a bottleneck. The solution? A road over the tracks.
What we are building is a bridge for the first time in the city of Mumbai that connects the eastern part to the western part. This is going to be one of the 2 major east-west corridors connecting Mumbai.
Milan Dave is charged with engineering a road to rival the Sea Link bridge, a highway that's truly high. The Santa Cruz-Chembur Link Road will be one of the first major roads to connect Mumbai east and west, and the first double-decker roadway in India. To support its enormous weight, its foundation will be sunk up to 19 meters below the swampy subsoil, into firmer bedrock below. On its deck, a superstructure unlike any in India. 2 levels of roadway, strong enough to withstand the winds of monsoon season. The flyover is actually composed of layers upon layers to spread out the crush of traffic. The upper layer feeding east to west, and the lower north to south. The flyover represents the critical transformation in Mumbai's roads. It's so crowded here, there's simply no room for lanes on the ground. The entire road is 6 kilometers long, but to cross the busy railways below, 2.5 kilometers will be elevated. Due to lack of land, the roads have to be built in the sea or in the sky. This project reaches for the sky. The flyover takes engineering in Mumbai to new heights. Yet the greatest hurdles to building in mid-air lie on the ground.
One of the biggest problems we face is the constant traffic flow. This is the only road in and out, the only access to the double-decker bridge we're building, about 2 blocks from here. And this is where most of my concrete trucks get stuck up, sometimes for hours at ends.
But the biggest obstacle remains the one that dogs all of Mumbai: people. More than 60% of the population lives in slums, many in shanties built illegally on government land.
This is the center line of the new bridge or the new road that's going to come up. There's about 4,000 people that live right now along the alignment, mostly in such slum pockets. And this is where a 45-meter wide road will be built shortly. I literally could stand in one of these places and point out to you the edge of the road, which would be somewhere behind me in that house right there where the fan is.
The squatters have to hit the road so Mumbai can keep moving.
Government's asking them to move to different parts of the city.
Move thousands of people in order to move ahead or screech to a halt. It's a terrible choice, but to many in this megacity, there's no choice. Mumbai has no option but to plow ahead.
If we did not build things like this, simply it would come to a standstill. Yes, railways is clearly the lifeline of the city. But side by side, they have no choice but to build some wider roads and wider bridges.
Not quite. A third option looms: build higher. It's a combination train and bus called the Sky Bus. It has yet to arrive in Mumbai, but a prototype was already running in the Indian state of Goa. A cure for congestion, traveling at 100 kilometers an hour. Each car hangs from rails 10 meters above the ground on flanged wheels. The same technology that keeps conventional trains on track, but upside down. With the car below, safety rises. Tracks are never blocked by other vehicles, or animals, or people.
It can never lose control, nor fall down, nor turn turtle. I mean, it is a safer system than the 150-year-old railway system.
Rajaram Bochi, the inventor of the anti-collision device for trains, dreamed up the Sky Bus. It's a homegrown solution to a homemade problem. In Mumbai, virgin real estate is as scarce as it is expensive. But the Sky Bus doesn't need 1 hectare of open land. It could run along the medians of Mumbai's highways. Rajaram designed the cars for the crowds of Mumbai. Each door is 4 meters wide. Easy in, easy out. No jostling and shoving. Each car can hold 150 passengers. Altogether, the Sky Bus could move as many people as a conventional train. It can even carry container cars.
In my opinion, no city can live without the Sky Bus solution.
Perhaps. But speed simply buys time. Inevitably, rails and roads will be overwhelmed. Moving people faster isn't enough. This megacity must move people somewhere else. To save Mumbai's vital organs will take radical surgery, a transplant of epic proportions. On the edge of the Arabian Sea, the future is under construction. The world's largest planned city. It's called Navi Mumbai, New Mumbai. Once it was empty marsh. Now, through ingenious methods of water drainage and flood control, the land is being reclaimed. The goal? to siphon thousands of businesses and millions of people from the old city. Already, 1.2 million people live here, barely a third of the new city's capacity. To avoid the mistakes of old Mumbai, Navi Mumbai is designed to move people efficiently and easily. Engineers build from the spine out. And once again, the backbone of growth is the railway. This is the gateway to Navi Mumbai. Every day, 400,000 people pass through the station. It was designed to handle 300,000 during rush hour alone. Underpasses let commuters easily cross the tracks and prevent the daily fatalities of train travel in Mumbai. Platforms 12 meters wide, the envy of the old city, prevent crowding.
The station has been designed to disperse the crowd, so that in less than a minute, everybody out.
Mr. R.K. Char is one of Navi Mumbai's city planners. He was also one of the first 10 residents. When he came here, he found a city underwater. Like Mumbai, one island made from 7, Navi Mumbai is made by reclaiming the land.
Here in this area, the soil is very bad.
Cha is standing on 12 meters of clay. When saturated, it has all the strength of a sponge. Before engineers can build a road, they have to extract the water. First, using a crane, they drive hundreds of perforated rubber pipes into the subsoil. Then they cover the ground with earth, sand, and a heavy layer of stone or gravel. Like a sponge being squeezed, the subsoil releases its water, up the pipes and across the roadside. Now they can build. Also, like Mumbai, much of Navi Mumbai lies at sea level. Unlike the old city, the new one rarely floods. Along the shore, engineers have built more than a dozen holding ponds. They hold excess groundwater, rainfall, and treated sewer water. Water flows out through a mechanism as ingenious as it is simple. No pumps, no electricity, just the natural force of daily tides, and a system of automatic gates. Mumbai is one of the few megacities in the world with a strong tidal surge, a full 4 meters.
During the low tides,
when the water is higher than this level, it will open.
Pressure inside the holding pond forces the gates open, and the water rushes out to the sea. During high tide, the pressure of rising water forces the gates closed and keeps the sea at bay. If it floods, the ponds fill up and keep the water from flowing into the city. If the ponds were to overflow, electric pumps stand by, ready to pump out millions of liters per minute. Yet the gates and ponds work so well, the pumps have rarely been used. In Navi Mumbai, the old city sees its mirror image. A city invented by Indians, not colonizers. A modern metropolis striding toward the future, not an ancient city struggling to keep up.
Our laboratory has been Mumbai. The success of Navi Mumbai will be the solution of Mumbai.
In Mumbai, the new is coming to save the old.
We are now looking to give Mumbai a new life. We have everything. We have the money now. We have the people, we have the talent, and we have the promise of future.
The future once promised paralysis, but no more. Today, Mumbai is stirring into action, bridging an ancient gulf of doubt and spanning the limits of the imagination.